Okay, today we will go over the material from the previous test that we went over on Monday, the one that I marked in blue. Or maybe not marked in blue, but let's see. Okay, the one that I marked in blue. Yeah, the thing is this number 4 here, I cannot do that yet. Well, I can, but yeah, 4 and 5. The one that I marked in blue only. So this one needs to wait until Monday. This one needs to wait until Monday. But those are easy. Yeah, we need to wait until Monday. This one, we still need to wait until Monday. Also, basically only one question we can do. Huh? To wait until Monday. Basically, I have not covered that in the other class. Monday. So there's only one problem we can do this time. Okay, it is related to the inequality. So the one that I say I will do today. Yes, it's okay. Yeah, somebody said that she's a bit behind and would like to watch the last video. Go ahead. Yeah, I'm recording this. Okay, so I will do number 6 from here, and then I go to part B of that 417 later on, and then we will start working on a new old test 1. Okay, unfortunately from this test here, there's only one more problem we can do. Yeah, so it's basically, this is what we need to solve, right? To find the domain of this square root thingy. Then it means the radicand, the guy inside the house, has to be non-negative. This has to be non-negative. Then we start the procedure. Remember, anytime we solve rational or polynomial inequalities, we need to do that 3-step procedure. Okay, so the first one, critical numbers. I rewrite it and set it equals to 0. So I covered this yesterday in the recording from yesterday, and then I factor. By the way, if you can factor right away, go ahead. You can skip that little step. I don't mind. Yeah, as long as the other side you set equals to 0. And this is 2x, I think, 2x and x minus 3 plus 1. Okay, so the critical numbers are negative 3, 3, and this is actually multiplicity of 2. Multiplicity of 2. It happens once on the top, once at the bottom. And then the last one is x equals to negative 1/2. Is it okay so far? Okay, Morton.
Yeah, okay.
Okay, so then we go on with to do the sine graph. We do the sine graph. We have x equals to negative 3. That's the 0 from the numerator, right? And then x equals to negative 1/2. That's the 0 from denominator, so it makes it undefined. And x equals to 3. That's the 0 from numerator and denominator, so it's undefined. Now then, I pick the testing point. Let's say I pick x equals to 0. When x equals to 0, I get 0 plus 3. Maybe I write it down so that you guys know what I do. 0 plus 3 times 0 minus 3 over 2 times 0 plus 1, 0 minus 3. But what we really care is actually, is it positive or negative? Okay, so overall that will be positive, right? That's positive here. Now then, when I go to the left, notice that x equals to negative 1/2 is undefined with multiplicity of 1. It happens with exponent 1. So I will change the sign, right? When I cross that critical number, I change the sign. And then x equals to negative 3 is also 0 with multiplicity of 1. So when I cross this inequality sign, I mean, cross that critical number, I change the sign. Now, on the other hand, when I cross that x equals to 3, it is multiplicity of 2. 1 on the top, 1 at the bottom. So when I cross the critical number with even multiplicity, I don't change the sign. Okay, so you see it's actually a lot faster by you doing this method. Instead of doing the sign chart by our textbook, okay, this way is actually a lot faster. Now, the third step is the solution. So we need the 0 or positive, right? 0 or positive. So positive or 0. Okay, positive, positive. So the solution will be negative infinity up to negative 3, including negative 3, union negative 1/2 to 3, union 3 to infinity. Okay, that's for this question here. Let me mark it other color. Let me mark it in purple for the questions that we will do on Monday. Yeah, hopefully tomorrow we can start doing graphing for the other class. Yeah, there's a chance that some of them even need to wait until Wednesday next week too. Okay, those are the ones that we will do on Monday. The questions will be done in future. Okay, that's for the spring 17. Let's go on to fall 17. Fall 17, let's see which question we can work on here. This one we need to wait. Difference quotient, something we need to wait. Or actually, I can start working on that because you guys will see that's supposed to be tomorrow. Or the what's that? Difference quotient. But I guess not. I guess not. Let's see later. Let's see later. Okay, these are the one that we will do on Monday. This is still on Monday. So not a lot, huh? But on the other hand, if you remember that if you watch the lecture, right, I believe you can do those already. You know, it's on the transformation, graph and transformations. So these are the one we can do on Monday. I will see later on. I plan to do this. Let me go over. So this is the one we can do right now. So this is the one we can do right now. This is the one we can do right now. That's the one we did just now, actually. Let me do this number 13 first. Okay. My plan is this. After I do all the blue ones that the inequality, then I will start a new alt test. I think that's from spring 19. We do whatever we can, right? And then if we have extra time, then we will look back and start thinking about the transformation. Okay, let's look at this one. So this number 13, find the domain of the square root of blah. Well, square root of blah means the guy inside the house, the guy inside the radical has to be non-negative. So critical number, 2x squared plus 3x minus 2 over x squared minus 4. Set it equals to 0 and then factor. Again, if you can factor right directly, go ahead. So from here we see that the critical numbers are 1/2. That's multiplicity of 1. Okay. X equals to -2. That's multiplicity of 2. Okay. I have a habit like this. If it is multiplicity of 1, I don't say anything. I don't write it in this case. Okay. Unless I specifically ask you, okay, write the multiplicity 2, then you should. Okay. But this one just to help me with my work in step 2, right? So only the one that other multiplicity, then I will write it down. Second, I do sign graph. X equals to -2. That will give me undefined because it's on the top and the bottom, right? Comes from here and here. Okay. And then when x equals to 1/2, that's the 0 from the numerator, and then x equals to 2, that's the undefined. Now then I do testing point. Usually the easiest one to use is actually find the y-intercept, right? So x equals to 0. When I plug x equals to 0, I will get on the top left, it will be negative. On the top right, that will be positive. On the bottom left, that's positive. And then bottom right, that will be negative. So overall, that's positive. Okay. Now then, I will jump across the critical number. Right? -2 is a critical number with multiplicity of 2. So when I jump across that, I don't change the sign. Yeah, if it is even multiplicity, don't change the sign. 1/2 is multiplicity of 1, so I change the sign. 2 is multiplicity of 1, so I change the sign. See, a lot faster, right? Okay, so in step 3, what do we need? I need that to be positive or 0, right? Because it's inside the radicand, right? Let's look back what we are working on. Yeah, it has to be inside the radicand, so inside the square root. So the radicand has to be greater equals to 0. So positive, positive, including 0, and then positive. So it will be -infinity up to -2 union -2 up to 1/2, including 1/2, union 2 to infinity. Okay, that's for this question. Do you have any question, Morton? It feels like I'm tutoring you personally, which is good. So
No, I don't
please,
have any question.
yeah. So please interrupt me anytime you have any question. Okay.
Yeah.
Now number 12, we have this question is simpler, but plenty of people make mistake on this simpler question. The one that I have to warn you ahead is do not multiply by LCD. So don't do this. Multiply by x plus 1, and then you get 5 here, and then this is x plus 1 here. It seems to be very simple. Now, the reason is because we don't know if x plus 1 is positive or negative. That's the reason. That's the reason. Okay, that's why this method doesn't work. Okay, whoever does it that way will get it wrong. Will get the wrong answer. That's not right. That's not right. Okay, the way to do that is you subtract by 1 and simplify. So basically make the other side equals to 0. Okay, and then I will do the LCD. Okay, so that I can make them into one single fraction, right? So 5 minus x minus 1 over x plus 1 less than or equals to 0. So 4 minus x over x plus 1 less than equals to 0. Now, let me start the procedure. You know what? Let me do this. Let me move this guy here a bit to the top. Okay, now then let me start the procedure on the left-hand side here. So the procedure, step 1, critical numbers. So actually you don't need a lot of space, especially an expression like this, inequality like this. So 4 minus x over x plus 1 equals to 0. So either x equals to 4 or x equals to -1. Step 2, sine graph. You have two critical numbers, x equals to -1 that give us undefined, and x equals to 4 that gives us 0. Okay, and then you do testing points. Let's say I pick x equals to 0. So on the top, 4 minus 0 is positive. At the bottom, 0 plus 1 is also positive. The quotient is positive. Now then, each critical number here, both there are two, both of them has multiplicity of 1, such that when I jump across critical number, I change the sign. Okay. Then step 3, we see, oh, I need negative or 0. So the solution will be negative infinity up to -1 union 4 inclusive to infinity. Okay. That's for number 12. Now let's see more. Is there anything else we can do from here? Yeah, piecewise defined function, we cannot do that yet. Because we need to memorize those basic functions that I will present tomorrow in the other class. I want to erase this and change it into purple color. Okay, let me give the explanation at the top. The questions marked in purple will be done in future. So you see that the material I will go over tomorrow will be very, very crucial because I will teach you how to deal with graphing basic functions, okay, and then difference quotient. Those are the ones usually take time. Okay, but we are not rushing though because your test is still 3 weeks in 3 weeks. Okay, 2.5 weeks. Okay, now I will start with a new set. I will start with a new set, and that is from, I will take it from spring 19. Let me take a look. Let me take it from spring 19. I post the blank test in our discussion board. Spring 19 Math 260 Test 1. I think we can do most of the problems here already because I remember this test is a special test because I gave them they only have 1 hour to do this problem. It was an everyday class. So I believe most of the problem here is doable already, if not all. Okay, but let's take a look. This is from Spring 19 Math 260 Test 1 solution. But let's take a look how far we can do in this problem. Solution. Oh, this question is very similar to what we did before. Okay, consider these two coordinates. Find the equation of the line passing those coordinates. So the first step, I will need to find the slope, okay, which is y2 minus y1 over x2 minus x1. This is 8 over negative 6. That's negative 4/3. That's the slope. So the equation of the line must be y equals to negative 4/3 x plus a constant. Then I use either one of the coordinate. I will use the first coordinate. Okay, so y is negative 2, x is negative 1. I'm sorry, x is positive 1. And we will solve for b. Negative 2 equals to negative 4/3 plus b. So negative 6 over 3, that's for my negative 2, plus 4/3 equals to b, that's negative 2/3. Therefore, the equation of the line is y equals to negative 4/3 x plus 2 minus 2/3. Okay. Part B. Find the equation of circle whose diameter is a segment with endpoints with those two coordinates as endpoints. So the endpoints are 1, negative 2, negative 5, 6. Now we need to find the equation of the circle. But this is diameter, so the center must be the midpoint, right? Okay, the center is equals to the midpoint, which is 1 plus negative 5 over 2 for the x component, negative 2 plus 6 over 2 for the y component. The midpoint is negative 2, comma 2. And then the radius squared will be the distance from the midpoint to either one of the coordinates. Okay, that's the radius. So let me use the midpoint and negative 5, 6. Okay, I will use negative 5, 6 here. Okay, so negative 5 minus negative 2, x2 minus x1 squared plus y2 minus y1 squared equals to the distance squared, in this case the radius squared. Now, by the way, the nice thing is you don't actually need to find the r later on, because in the equation of the circle, what you need actually r squared. Okay, so negative 3 squared plus 4 squared equals to 9 plus 16. So r squared equals to 25. Of course, you still can say that the radius equals to 5, right? Okay, but what we really need is actually equation of the circle, which is x plus 2 squared plus y minus 2 squared equals to r squared. Okay, this negative 2 and 2 appears here. Okay, and then the radius squared. Then part C, find the x-intercepts of the circle from part B. X-intercept means the y equals to 0, right? So if y equals to 0, I will get x plus 2 squared plus negative 2 squared equals to 25. And then I will solve for x. Okay. I will keep this in squared form because we actually get a perfect square there. So this is 25, so this becomes 21. So x plus 2 equals to plus minus square root of 21. Don't make it decimal. You can, if you can simplify, but when we say simplify, it doesn't mean make it to decimal. Okay, yeah. When suppose we have square root of 24. When I say simplify, you see it this way. Oh, this is 4 times 6, so this is 2 square root of 6. Okay. When I say simplify, this is what it means. I'm not saying, oh, this is actually 4.8 or 4.9 something. That's not what we mean by simplify. Okay. Simplify means you still have the exact solution. Okay. Now, converting it to decimal is called approximate. Okay. Let's come back there. And x equals to negative 2 plus minus square root of 21. But we are not done yet. The question is not find the x. The question is find the x-intercepts. Okay, so the x-intercept should be written in x-intercept forms. That is, it has to be in coordinate. Okay, it has to be in coordinate and separated, of course. Okay, that's for part C. Let's go on with number 2. This number 2 here, I will show you 2 different ways to do this for this number 2. If you watch my lecture ahead, right? Because in 2.3, then I will go over the shortcut, right? In my lecture on 2.3. But if you watch my lesson 5, I believe you saw that already. If you watch my lesson 5, I believe you saw that already. So we have one line, 3x minus 5y equals to 6. And another line perpendicular to that line 1. Line 2 contains 4, negative 3. Okay, now I will show you the first method first, okay, the long one. This is how an algebra student will do it. Method 1. Can I use this method, Thomas, even though that's from algebra? Yeah, you can, but don't blame me if it's way too long. Okay, method 1. Our line 1 is 3x minus 5y equals to 6. I need to find the slope. So divide by negative 5, that's 3/5 x minus 6 over 5. So that's the slope of line 1, 3/5. Okay, therefore the slope of line 2, the one perpendicular to that, is negative 5 over 3. Right? Now then, I will continue line 2, therefore given by y equals to negative 5 over 3x plus b. And continue here. I plug in coordinate. Okay, the y is negative 3, the x is 4. So I get negative 3 equals to negative 20 over 3 plus b. Do the LCD, negative 9 over 3 plus 20 over 3 equals to b. I don't really like this though, because the equal sign is not straight all of a sudden. So when I solve this one equation, okay, but well, one time is okay. So that the b is 11 over 3. Therefore, the equation is y equals to negative 5 over 3x plus 11 over 3. Now, the thing is, the original equation is given to us in general form. Okay, I don't mind you answering me here, but usually, your answer should be also in general form. So let's multiply that by 3 to get rid of the fraction. And then I will move the 5x to the other side. So our final answer in standard form is this. That's our equation of line 2. Okay. Now that's for method 1 though. That's for method 1. Let me do method 2. I squeeze it somewhere here. Let me do method 2 here. I squeeze it somewhere here. Okay, method 2. A precalculus method. Okay, now notice that line 1 is 3x minus 5y equals to 6. Now line 2 is perpendicular to that, right? So line 2 must have this pattern. You switch the coefficients of x and y. Okay, so coefficient of x is 3, coefficient of y is -5. You switch the coefficients and change one of the sign, not both, only one. So I will change that -5 becomes +5. I will change that, I will keep that 3 as 3. So I will have 5x plus 3y equals to constant. So every line perpendicular to line 1 must have this pattern. Remember when you try to find the slope of the second line, you actually do the reciprocal and take the opposite, right? So the interpretation is the coefficient of x later on becomes coefficient of y. Coefficient of y later on becomes coefficient of x. But you need to change either one of the sign. So that movement that we did there, actually we reinterpret that here. Okay. However, you will not see that procedure as a shortcut if you don't show your work properly. Okay. After doing this many times, then you're supposed to realize, oh yeah, you know what? When we try to find the slope of the perpendicular line, I flip that upside down and change the sign, right? But that flipping means I also swap the coefficient of x becomes coefficient of y becomes coefficient of x, and I change one of the sign. Now, then, what next? How to find that c times? Well, plug in the coding. Okay, plug in the coding. So I will plug in 4, -3. So 5 times 4 plus 3 times -3 equals to c. 20 minus 9 equals to c. c equals to 11. So my line 2 is given by 5x plus 3y equals to 11. Okay, that's how we will do that question number 2, using precalculus method. Now this question is 6 points. Okay, you should think of this as a hidden extra credit, because if this is the amount of work you need, that should be at most 3 points, right? That should be at most 3 points. Okay, I give you 6 points for what? For this. If you do it with method number 1, then it will take you approximately 4 or 5 minutes, right? Okay. If you do it with method 2, it's supposed to be at most 3 minutes. Then you have extra 3 minutes that's supposed to be for this question. Yeah, this question is 6 points, right? Okay, so when you do that, you should take you at most 6 minutes. Okay, but if you can use a shorter method, okay, I don't even want to call that shortcut, because as a pre-calculus student, you're supposed to know that. And that's why I thought that. Okay, but if you do that shortcut, then you actually save 3 minutes. That's supposed to be for this question number 2. And that's 3 minutes that you save. You can do that. You can use that for other question in case you need it. Okay. The nice thing about this this class is the number of points for this test is 105 points. So if you are well prepared, then it should take you at most 105 minutes. At most 105 minutes. My test in your class, however, is 150 minutes. Okay, yeah, 150 minutes. Well, anyway, let's come back. Continue with number 3. Number 3. We have this function. Find the domain and write the solution in interval notation. The domain will be all real numbers except 4. Right? Yeah, all real numbers except 4. Now, I consider this interval notation, but if you don't want to call that interval notation, you can write that in the real interval notation. Okay, but I do accept this one. I do accept this as interval notation. Okay, even though other instructor may not accept that as interval notation. Okay, this is the real interval notation though. Okay, but in my class you can use either one. In my class you can use either one for interval notation. Now, part B. As a background on question part B, which I will explain after I'm done with this question. Okay, this one question. The question is basically solve for x. So you have that y equals to something and you want to solve for x. Okay, the first step is I will multiply by the LCD at both sides, x plus 4, x minus 4. Okay, so I get y times x minus 4 equals to 2x plus 3. Then I distribute xy minus 4y equals to 2x plus 3. Get the x terms on the same side, and the one without x, you move it to the other side. Then the key step is to factor the x out, and then the next step, we will divide by y minus 2. So x equals to 4y plus 3 over y minus 2. Okay, that's the question. Now, some lesson that we can learn here. At this point, we can actually work on something which I may mention this very far in advance, very far later, maybe like 2 weeks from now. Okay, 2 weeks from now. But this is the work we need to do if one of the method to find the range, maybe I write it this way in other color, note. One method, that's not the only method, that's one. Second, most of the time this method doesn't work, but this method is one of the acceptable method to find the range of a function. Okay, is what? Okay, let me go back first. We have this function. Okay, basically that's y equals to something. Now, if you want to know the domain, what kind of x we are allowed to plug in here, then you actually solve for y such that the other side only have x. Okay, you solve for y. Okay, the other side has only x. Then you look at what kind of x are we allowed to use. That's how we get the domain, right? We get the domain from this pattern, right? From this, we see what kind of x we can use, and that's how we know our domain. Now, then how to find the range? What we can do is we solve for x. Okay, like what we did in part B, and then read what kind of y, or you see, read which y is okay. What kind of y can we use for this expression? We can use any y except 2. So the range will be maybe from here, then you will see the range is all real numbers except 2. Does it make sense? Right? That's a question that we didn't know how to answer yet. Okay, in fact, that's a question we will answer once we get to pretty far into chapter 3, toward the end of chapter 3. Then we can answer it by first knowing what the graph looked like. But at this point, we can only already answer that question by using this method. Okay, by using this method, you basically have y equals to something in terms of x, y equals to something in terms of x. Okay, yeah. You solve that the other way around. You rewrite that as x in terms of y. Then from there you see what kind of y you can use. Sometimes it's easier to see what kind of y you need to avoid, right? Here you say, oh, I need to avoid 2. So the range will be all real number except 2. The range of this function is by looking at the domain of the inverse. Okay, now that's for the background in this question B. So the reason I asked that those students at that time, including you later, about this question is to prepare you to answer that range question in future. Okay, so instead of asking you that, the big chunk of question in future at once, I set you up already to answer that question starting from now. Okay, and this question is actually a common question, but not, how to say that, a common question for those who go to Precalculus, to calculus, and of course then you learn that in Precalculus. But instructors who don't really teach calculus classes, therefore they don't really ask this question. Okay, so it depends on what kind of instructor you get also. If that instructors get used to teach calculus, then the way they train you for in Precalculus class tends to be more appropriate, let me say. Okay, the difficulty level is more precise. Number 4, 2x plus 1/3 being squared equals to 8/9. This is a perfect square, so I will apply square root property both sides. But square root of 8 is 2 radical 2. Square root of 9 is 3. Now then, 2x is equal to negative 1/3 plus minus 2 radical 2 over 3. That's negative 1 plus minus 2 radical 2 over 3. Now I will divide by 2. But dividing by 2 is the same to multiply by 1/2. Right? Okay, so x is equals to negative 1 plus minus 2 radical 3 over 6. Now split it. X1 is negative 1 plus 2 radical 2, not radical 3, 2 radical 2 over 6, and then negative 1 minus 2 radical 2 over 6. Okay, with some extra warning note. Okay, negative 1 plus 2 radical 2 is not equals to radical 2. They are not like radical. One of them without radical, the other one with radical. So you cannot combine them. Okay, you cannot combine them. Okay, to clarify that, suppose I have 3 plus 2 radical 2. You cannot call this 5 radical 2. Okay, why? Because 3 is without radical 2. Okay, 2 radical 2 has that radical. In other words, the radical 2 only applies to the second term, not to the 3. Okay, so you cannot combine them. Okay, That's for number part A. Let's go on with part B. Absolute of blah equals to 6. Absolute of blah equals to 6 means 2x minus 3 over x plus 4 is equal to 6, or 2x minus 3 over x plus 4 equals to negative 6. Right? It is based on absolute of blah equals to a positive number implies blah equals to that positive number, or blah equals to the opposite of that positive number. Okay, now then we solve that one by one. It is equation, so I can multiply by the LCD. 2x minus 3 equals to 6 times x plus 4. My equal sign is slanted, but that's because I need some space. I need that color. Use different color. Okay, and then I solve that. I get 2x minus 3 equals to 6x plus 24. Subtract by 24. Subtract by 2x. So x is 27 over 4. Now, because the other side is positive, then I don't need to check. 2x minus 3 equals to negative 6x plus 4. 2x minus 3 equals to negative 6x minus 24. Add 6x, that's 8x, minus 3, negative 27x. I don't expect it to be. So, oh no, no more x, sorry. No, not negative 27, it's negative 21. Okay, so x equals to negative 21 over 8. Yeah, I knew something was wrong earlier, that's why it's like, something not right here. Okay, so this is part B. I hope you don't see this as anything new though. Nothing new here. Every time you have absolute something equals to a positive number, the first step always split that into the positive branch and the negative branch. Okay, but what happens if the inside is, no, doesn't matter if the guy inside the absolute sign is however ugly, okay, as long as that absolute is equals to 6, then the guy inside has to be either 6 or negative 6. What will happen after that, we don't know, but just go on from here. Okay, so use simple idea to solve complicated problem. Now, you can only have that ability if you practice enough. Okay, let's go on with question. Oh, I have question C down here. Oh, now I have absolute of 3x plus 1 equals to x plus 3. Let me split that first. Okay, so either 3x plus 1 equals to x plus 3, or 3x plus 1 equals to negative of x plus 3. But because we don't know if the other side will be positive or negative, we need to check the answer later on. Okay, we need to check the solution later on against the original equation. Okay, so this is 2x equals to 2x equals to 1. This is 3x plus 1 equals to negative x minus 3. So 4x equals to negative 4. So x equals to negative 1. Check. When x equals to 1, I get 3 times 1 plus 1 in absolute sign. Is it equals to 1 plus 3? So that would be absolute of 4. Is it equals to 4? That's right, 4 equals to 4. Okay, now how about when x equals to -1? Absolute of 3 times -1 plus 1, is it equals to -1 plus 3? That's absolute of -2, is it equals to 2? Oh, that's true, right? That's true. Okay, so both of them are solutions. So x equals to 1, x equals to -1. Let's go on further. Part D. 2 something squared equals to 13 of the same thing minus 7. I notice that this is actually quadratic-like equation because for this term, the variable part is the square of the variable part here, and the other term is constant, right? So I will use quadratic-like equation method. Let x to the 2/3 equals to u. So the equation now becomes 2u squared plus 13u minus 7 equals to 0. Oh, a student asked me this yesterday in my West LA College class. Thomas, there are so many ways to solve a quadratic equation. So can I just use any method? The answer is if, and I believe I mentioned this before explicitly, I even wrote it down that if that quadratic equation is solvable by factoring, then you need to solve it by factoring. If it is solvable by factoring, then you need to solve it by factoring. Okay, what happens if I use quadratic formula, Thomas? I still get the same answer, but I will penalize you 1 point because you don't recognize it is factorable. Okay, the risk is this though, if it is factorable, then you can do it fast. Okay. Now, if you don't recognize that it's factorable and you actually do it with quadratic formula, you will spend too much time. Okay, so before you complain, Thomas, your test is too long, let me penalize you first for using wrong method. Okay, wrong method not because you get wrong solutions, but because you actually dedicate too much time unnecessarily and still think about complaining. No, if it is factorable, you should recognize that. Okay, at this point, factoring is something you should be able to do fast and even recognize that fast. Okay, basically every time you have quadratic equation, you always try to factor that first. Okay, now if you want to recognize that fast, if it is factorable or not, you mentally or on your scratch paper, you check the discriminant. Okay, b squared minus 4ac. If the discriminant a square number, then it is factorable. Okay, so the discriminant here is 225, which is 15 squared, right? So this is factorable. Okay, this is factorable. So this is 2u minus 1, u plus 7. So u equals to 1/2 and u equals to -7. Now I replace that u back as x to the 2/3. Okay. Now then take a look on how it is being written. So this can be seen as cube root of x being squared equals to 1/2. Okay. This is cube root of x squared equals to -7. Undo the cube root, I cube both sides. So x squared equals to 1/8. Let me go down, solve it further. So x equals to plus minus square root of 1/8. Okay, you will get x12 equals to plus minus multiply by 2 on the top and the bottom, I get this. Okay, on the other branch, x squared equals to negative 7 cubed, which is a negative number, right? Which is a negative number. So no solution from this branch. X squared cannot be negative. Okay, or to be more precise, it is a not real solution. Okay, so our solutions only radical 2 over 4, negative radical 2 over 4. Okay, so again, it is a quadratic-like equation. So I do substitution to make it look quadratic. From there, I solve it. Right? Somewhere in between, then after we solve for that u, we substitute that back in terms of x and then solve it further. Okay, and then when I try to solve it, it turns out that one of them give us x squared equals to a negative number, therefore no solution from that branch. Okay, so the journey for this question is actually a bit long. This is the appropriate question for precalculus level. But even at this precalculus level, it is considered the easy questions. Now, part A. This one is also a quadratic-like equation. Oh, you know what? Let me mention this. Okay, I did give extra points for students who actually go on and compute this branch here in complex number. Okay, so let me do it on the, so if you actually do it this way, it's like you didn't say no, you're supposed to say no real solution, but the extra point will be if you continue working on that. You say, oh, x squared equals to negative 7 cubed, so x equals to plus minus square root of negative 7 cubed, which will be negative plus of 7 radical 7 I. I'm sorry. No plus. It's not like that. It's plus minus here. So x3, x4 are complex numbers, 7 radical 7i, negative 7 radical 7i. Okay. For students who does it that way, okay, I give them extra 2 or 3 points actually for this question. You know, which I think is not too hard. Okay, it's not too hard. But of course, they need to say that these are not real solutions though. In other words, if I try to plot this on number line, you will have only 2 solutions on the number line. The other 2 solutions will be on complex numbers. Okay, imaginary number to be more precise in this case. Okay, that's your extra points. Now, going back here, going part E, this is quadratic-like equation. Okay, notice that x to the 4th is the square of x squared. So I will say let u equals to x squared, such that my equation now becomes 4u squared plus 5u minus 6 equals to 0. Now factor that. 2. No, it won't be 2. It must be 4u and u plus 2 here minus 3 here. So u equals to 3/4, u equals to negative 2. So x squared equals to 3/4, x squared equals to negative u. So you should say no real solution. but you can go on from there. Okay, let me do the left hand side first. So x equals to plus minus square root of 3 over 2. So x12 is square root of 3 over 2. X1 is square root of 3 over 2. X2 is negative square root of 3 over 2. But if you want extra credit, maybe 1 or 2 points, then you say x equals to plus minus square root of negative 2. So x3 is radical 2i, right, which is square root of negative 1. And x4 is negative radical 2i. Okay, now there you get 1 extra point. I think this one is quite easy. So I give only 1 extra point. If you show that, just make sure that you first state that there's no real solution from this branch. And then you go on here. Okay, that's for part E. This Precalculus class, we not deal with imaginary number. So if the solution is supposed to be imaginary and you don't do it, as long as you say no real solution, I'm fine. However, if you can find the imaginary number, the imaginary solution, then I give you extra points there. Okay. Let me take a little break here. Let me take a little break here, and then we come back at 10:45. Let's make it this way. Let's come back at 10:50, and let me ask you to do the one that you see on your screen. Let me ask you to do number 5A and number 7A. Okay. No, 10:55. So 10 minutes break plus 10 minutes to do these two problems here. Okay. So 10:55, I will start working on this. See you later. So I will factor this first. This is x plus 3, x plus 2. Oh, this one is x plus 2, x minus 2. So I will multiply by the LCD, which is x plus 3, x plus 2, x minus 2. Now that will give us on the first term is 2 times x plus 2, x minus 2 minus 4 times x plus 3 equals to x plus 1, x minus 2. Let me FOIL this. This is 2 times x squared minus 4. And the one here will be x squared minus x minus 2. Distribute. Combine like terms. Set one side equals 0 because this is quadratic. So I get x minus 6, x plus 3 equals to 0. Either x equals to 6 or x equals to negative 3. But I have to cross this out because it will make this denominator become 0. Right? Okay, and you see that x plus 3 cannot be 0, x plus 2 cannot be 0, x minus 2 also cannot be 0. Therefore, our solution is only x equals to 6. That's for part A. Number 7A is actually supposed to be the consider this a bonus question. Yeah, absolute of blah is greater than a positive number means that blah is less than negative 4 or that blah is greater than 4. and then solve it. 3x is less than -9, x is less than -3, or 3x is greater than -1, x is greater than -1/3. Now the solution should be written in interval notation unless I say otherwise. Okay, so the solution is -infinity up to -3 union -1/3 to infinity. Okay, let's go back to number 5b. We have quadratic radical equations here. I have radical equation here. Isolate one of the radical. Let me isolate square root of x minus 2. So the other side I have 5 minus square root of x plus 3. And then I square both sides. Now, because I square both sides, then later on, whatever solutions we have, we need to check against the original equation, because we don't know if the other side is not constant. The other side, both sides has variable. Right? So the left-hand side, we get x minus 2. The right-hand side is 5 minus square root of x plus 3 quantity squared. So x minus 2 is equals to 25 minus 10 square root of x plus 3 plus x plus 3. Okay, remember what I did was actually distributing or foiling this a minus b squared. Okay, that's what we did. We are not squaring term by term. We are squaring the side, the left-hand side, and the right-hand side. So the left-hand side stay the same. The right-hand side is x plus 28 minus 10 square root of x plus 3. Cancel the x, subtract by 28, divided by -10. I somehow feel that I did this problem last time. Maybe I copy-paste the question. I forgot. And then I square both sides. So x equals to 6. So notice that I square both sides twice. The second squaring both sides is not a problem because it's already positive on the other side, right? It's already positive on the other side. But still, we still need to check because the one here, when we square both sides, we don't know if the other side is positive or negative. Basically, if the other side has variable, then you have to check. Okay. Now then I need to check when x equals to 6, square root of 6 minus 2 is it, I'm sorry, 6 plus 3. First, plus square root of 6 minus 2, is it equals to 5? And square root of 9, that's 3, plus square root of 4, that's 2, is it equals to 5? That's true. So x equals to 6. Part B of number 7. Actually, look at number 6 first. Number 6, I think I cannot do this yet at this point, but the idea is actually quite simple. The idea is actually quite simple. So I will leave it until Monday. Okay, I will leave it until Monday. But this, I will basically I will come back to this question. But this question is actually on the easy side. And as I remember, we will discuss this tomorrow. Yeah, we will discuss this tomorrow. We'll discuss this tomorrow. Okay, let's see number 7b. That's a polynomial inequality. Polynomial inequality, we need to set one side equals to 0. Okay, Okay, and then follow the three-step procedure. Critical numbers. 3x squared minus 19x plus 20 equals to 0. I believe this is factorable. 3x and x, no other way. Minus and minus, no other way. 5 here, 4 here to make it negative 19. So x is 4 over 3. X equals to 5. Those are the critical numbers. How about the sine graph? 4 over 3 is approximately 1 point something, right? Okay, so 4 over 3 is to the left of 5. Both of them, when we plug into the expression, will give us 0. Testing points, I will test x equals to 0. But when x equals to 0, you will see that's positive. Okay, that's negative times negative. Or you can also see this way. If you plug that x equals to 0 here, you basically get the y-intercept, right? The constant. Okay. You see? Okay. That's the benefit of using x equals to 0. So instead of looking at the factored form, you can just look at the original one, but you set all the x becomes 0. And that's the reason we use x equals to 0. Okay, so this is plus. And because each of these critical numbers are multiplicity of 1, then when I jump across the critical number, I change the sign. Jump across the critical number, I change the sign. Then we see what we need is positive or 0. So the solution will be from negative infinity to 4 over 3 inclusive union 5 to infinity. Okay, now let's go on to the last page. Out of these 4 pages, we are done with the first 3 pages and we skip one question. Oh, this one here. Last question here. Okay. Number 8a, that's solving inequalities again. That's polynomial. So step 1, critical numbers. X squared plus 4x minus 2 equals to 0. You will see this is not factorable. You will see this is not factorable. You can try that b squared minus 4ac, right? That's 16 plus 8. That's 24. That is not a square number, right? That's how we know that's not factorable. Well, so what if it is not factorable? Then use other method. You can use formula if you like, right? After all, you already have the discriminant earlier, but I think it's better for us to use completing the square here. I will add 4 divided by 2 and then square both sides. And square that, I will get 4. So that's the number I will add both sides. So I get x plus 2 squared equals to 6, right? So x plus 2 is plus minus square root of 6. X are 2, negative 2 plus minus square root of 6. And then the sine graph. Of course, we know the negative part will be on the left-hand side. The positive part is on the right-hand side. Now, the thing is we don't know where is x equals to 0. Yeah, we don't know where is the position of 0. Okay. Now, to find out, you can use calculator to approximate this if you want to. Okay. This one is definitely negative, right? But we don't know if this is negative or positive. Okay. You can visually see that though. You see that negative 2 is negative square root of 4, right? Okay, now square root of 4 and square root of 6, which is greater? Square root of 6 is greater. So if you subtract by 2 here, subtract by 2, you see that this expression, negative 2 plus 6, is greater than 0. Right? Okay. I mean, that's how I will estimate that. Okay, I don't need the exact value. I just need to know if this number is to the right-hand side of 0 or to the left-hand side of 0. But if you want to do it super fast, just use your calculator to approximate. But do not replace that, though. Do not replace this negative 2 plus radical 6 by a decimal. Don't. Just keep it as an exact number. Okay? Okay. The reason we do this is to approximate where's the location of 0. And we know that 0 is actually here. Why? Because this is positive. Right? This guy is positive. Means x equals 0 is here, okay, in between these two numbers. When x equals to 0, I will get the constant negative 2. So this is negative. Each one of them are critical numbers with multiplicity of 1, so I change the sign when I jump across the critical numbers. And then, so I need less than equals to 0. That will be negative 2 minus radical 6, comma, negative 2 plus radical 6. Okay, that's for part A. Now I remember in this spring 2019, I taught an everyday class, so the test only for 1 hour. So what happened is your test one your test one is equal to their test 1 plus part of their test 2. Okay, it's your test 1 plus part of your test 2. Yeah, therefore, I think later on, if we have a chance, we'll take a look on their test 2 and see which question we can do. Okay, but let's finish this first. That's for 8A. Let's see 8B. This one. Rational inequality, that is a bit tricky. If you get used to it, you don't see that as tricky. But the tricky part is like a lot of students misunderstood and they think they can just multiply by x squared minus 4. That's a big no-no. Because we don't know if x squared minus 4 is positive or negative. That's why we don't do that. Okay. The purpose is we need to set one side equals to 0. Okay. So what I will do is I will subtract by 1 and simplify. So I get 5 minus x squared plus 4 over x squared minus 4. That is 9 minus x squared over x squared minus 4 less than equals to 0. You know what? Let me use this space and factor them. So 3 plus x, 3 minus x plus 2, x minus 2 less than equals to 0. And then I continue here. Okay, so the first one is critical numbers. 3 plus x, 3 minus x plus 2, x minus 2 equals to 0. The critical numbers are negative 3, 3, negative 2, and 2. So for the sine graph, we will have this configuration, -3, -2, 2, 3. Undefined for the critical number coming from the denominator, and 0 for critical numbers coming from the numerator. Testing point x equals to 0. So when you plug in x equals to 0 here, right before you factor it, you will get 9 over -4, right? Of course, you can also plug that into the factor form. When x equals 0, you have 3 times 3 over 2 times -2, right? Either way, you will get 0 here. Next, next, each of these critical numbers are of multiplicity of 1. So every time I jump across that any critical number, I change the sign. Finally, then I see I need negative or 0. I need negative or 0. Give me a second. Okay, so I need less than or equals to 0, the negative part. So the solution will be from -infinity up to -3 bracket union -2 up to 2 union 3 to infinity. Okay, that's for this question. Let's go on with part C. Part C, we have rational inequality again. The other side already 0, so let me go to critical number right away. So 2x squared plus 3x minus 2 over x squared minus 4 equals to 0. Then we factor x plus 2, x minus 2 equals 0. So the critical numbers, 1/2, x equals to -2 with multiplicity of 2, and x equals to 2. Sine graph. -2. That's multiplicity of 2 because we have, it comes from one on the top and another one from the bottom. That's how we get that multiplicity of 2. Okay, but because one of them from the bottom, then when you plug that in, -2 is a critical number that gives us undefined. Okay, 1/2 will give us 0, 2 will give us undefined. And then we test x equals to 0. It's between negative and positive number, right? Now, when you test x equals to 0, you can use that one. You can also use this one. Okay. Now, the nice thing about using x equals to 0 is then the x terms will become 0. You just compute the constants, right? -2 over -4, that's positive 1/2, right? Positive. Okay, so that is positive here. Now then, if I go to the left, -2 is a critical number with even multiplicity, so I don't change sign. Okay, 1/2 is a critical number with odd multiplicity, I change sign. 2 is a critical number with odd multiplicity, I change sign. Now then from here, I see I need negative or 0. I need less than or equal to 0. So based on that sign graph, negative or 0 will be from 1/2 to 2. Okay, now last question from this test. So we only skip one problem, huh? Now this seems to be something we cannot do yet. Okay, this seems to be something we cannot do yet. But with little work, we actually no, we cannot do that yet. But let me just say this. Okay, the idea will be as the following: quadratic equation has two real solutions if the discriminant is positive. Now, that's something we learn in further into chapter 2. Okay, something we learn further in chapter 2. It has two real solutions or two real roots if the discriminant is positive. I think I covered that when we did solving equation in 1.4. Right? Okay, now going back to this question then, okay, this quadratic equation, if I write it in, if I set one side equals to 0, this is what I get. Has two real solutions, when the discriminant is greater than 0. But what is the discriminant here? That's b squared minus 4ac. So k squared minus 32 is greater than 0. Now, how do you solve for k there? Notice that that's a polynomial inequality, right? Yeah, polynomial inequality. So your step 1 will be create critical numbers. Long time no see, huh? K squared minus 32 equals to 0. Okay, I don't think that's factorable. Let me use square root property, square root of plus minus square root of 32. That's 16 times 2. So that's plus minus 4 square root of 2. Those are the critical numbers. Sine graph. Negative 4 radical 2, 4 radical 2, both of them will make them 0. So this is positive. Yeah, you do the testing point, then you will see that when x equals to 0, the sign is negative. And each of them are critical number with odd multiplicity. Now you look back and say, oh, I need the positive part. So the solution will be from negative infinity to negative 4 radical 2 bracket, including 0. Oh, no, I'm sorry. Not including 0. No, my bad. No, not including 0. Union 4 radical 2 to infinity. Okay. Now let me put a marking on that one question that we didn't do. This one here, number 6. Okay, let me write on the top. The question, there's only one here, mark in green. will be done in future. Okay, one more question from there. Okay, so let me change the title here too. Let me change the title here with part A. Okay, now let's see their test 2. Let's see their test 2. I think most of them is not doable for us yet because we don't even finish our material yet, you know. We have not even finished our material. So there's a big chance the first half, even the first half of their test 2, which is the last 1/3 of our test 1, is not doable yet. Okay, but let's take a look. Let's take a look. In fact, I can circle the ones you will see in your test 2. Okay, maybe I mark it this way. This one here. The questions mark using that purple highlight will be in your test 2. Instead of your test 1. Okay, so the one I marked in purple will be in your test 2. Composition of function is the beginning of test 2, your test 2. Okay, this one will be in your test 1, but later. Okay, but we can find y-intercept and x-intercept already. Let's do it later. So let me mark this. This will be something you do in the next meeting. Something you do in the next meeting. This is something we do in the next meeting. Okay, even though the y-intercept is something we can do already. It's something we do in the next meeting. Something we do in the next meeting. Oh no, that one. Yeah, that's something we do. No. That's actually test 2. This part here is test 2. This part here is test 2. This one in the next meeting. Okay. It's still part test 1. This one in the next meeting. In the next meeting. Oh no, that's a part of your test 2. Well, let's call that part of your test 2. This one part of your test 2. But we can actually do that already. It's on the difficult side though. It's on the difficult side. So is there any question we can do already here beside the x and the y-intercepts? Nothing, huh? Yeah, nothing really. Let's do this one then. Let's do this one. Since I have time anyway. So let me just bring 19 math 260 test 2 solution part A. Okay. And We will do easy ones, the one that we know already. Here the y-intercept is when x equals to 0, the y will be -1/2. So the y-intercept will be 0, -1/2. How about the x-intercept? You set the fx equals to 0. And then to help with the work, I multiply by the LCD tool, maybe a -2 here to clean up the negative at the same time. So this is x squared plus 6x plus 1. It's not factorable, so let me solve by completing the square. 6 divided by 2 is 3, 3 squared is 9. I will add 9 to both sides. So I get 8 equals to x plus 3 squared, apply square root property. So x equals to -3 plus minus 2 radical 2. Therefore, the x-intercepts are -3 plus 2 radical 2, 0, -3 minus 2 radical 2, 0. Okay, that's for number 2, A and B, x-intercept, y-intercept. I think that's all we can do at this point. Actually, we can do this part also, part H, because we already get the critical numbers, right? Yeah, we already get the critical numbers. We get -3 minus 2 radical 2, -3 plus 2 radical 2. Okay, and then you will see when you do the sine graph, it will be negative, it will be positive here, negative here, negative here. So the solution is from -3 minus 2 radical 2 up to -3 plus 2 radical 2. Okay, now the better thing is if you already have the graph from part G, then this is actually a lot easier to solve because we already have the graph. Like at this point right now, we don't have the graph, so I create the sine graph myself. Okay, but if you already have your graph, you can just use that. You can skip the one that I boxed in yellow. Okay, this is something you can get right away by just looking at the graph. Okay, so for now, we use our the method that we had before. We have the critical numbers already, right? When we solve equals to 0, remember? When we solve equals to 0, that's our critical numbers, right? Let me go on. How about this one here? How to find the y-intercept? What is the function again? This is the function. So the y-intercept will be f0. F0 is 6 minus 2 square root of 4 minus 0. That's 6 minus 2 times 2. 6 minus 4, that's 2. That will give us the y-intercept 0, 2. Bang, that's easy. Right? See above. See the top of this page. The one here, not yet. Part A, number 6. Now that's test 2, right? But we can answer the y-intercept and x-intercepts already. Yeah, the y-intercept is what? P0. So P0 equals to -2 times 2 squared, -1, -2. -2 times 4 times -1 times -2. There are 3 negatives, so this is -16. So the y-intercept is 0, -16. Not too hard, right? How about the x-intercept, Thomas? Notice that it's already in factored form. I set the y equals to 0. and then solve for x, but again, the x already in the polynomial already in factor form. So the solution for this is -2, 1, 2. So the x-intercepts are -2, 0, 1, 0, 2, 0. Those are the x-intercepts. Oh, construct the sine graph of px. Oh, we did that already. We have the critical numbers that we get from part B, right? Okay, so construct the sine graphs. We are not solving it. We are just looking at the sine graph. -2, 1, 2. This is 0, multiplicity of 2, right? 0, multiplicity of 1, multiplicity of 1. And the y-intercept is negative. So when x equals to 0, the sign here is negative. -16, remember? The y-intercept is -16. Now then, when x equals to -2, that comes from a square, right? Okay, so the multiplicity is even. So when I jump across the critical number x equals to -2, which is even multiplicity, I don't change the sign. The one here, odd multiplicity, I change the sign. The one here, odd multiplicity, I change the sign. You will see later on what is the interpretation of plus minus in our sine graph. Well, if it is plus, means the graph is above x-axis. If it's minus, means the graph is below x-axis. Okay. Again, number 7 is a question we cannot do yet for this part, but if you think about it, it's actually quite doable. If you think about it. Okay, it's actually quite doable. It requires some certain maturity though. Let's take a look. So we have coordinate 2, 3. And we have a line y equals to 3x plus 5. Now, let px be a point on that graph. So let's say this is point P, okay, coordinate xy. Now, of course, when we say coordinate xy, that's for the coordinate of P, but because this P on that line, then the y must be 3x plus 5, right? Okay, now take a look on the distance. So distance squared equals to x minus 2 squared plus y minus 3 squared. That's the distance squared, right? Now I will substitute the y now by 3x plus 5. So d squared equals to x minus 2 squared plus 3x plus 5 minus 3 squared. Okay, so d now as a function of x is a square root of x minus 2 squared plus 3x plus 2 squared. Of course, I actually expect you to simplify this, but at least you know this is the line of work. Okay, so the function d as a function, distance function of x on that line from 2, 3. Let me FOIL that. So d as a function of x will be square root of 10x squared plus 8x plus 8. Okay, now then we will use that fact later on to find the coordinate on this P closest to that line. Okay, what is this coordinate here that is closest to that line? Now, if you remember, we have this question actually in spring 19. Okay, if I have a point, find the distance from a point to a line. Find the distance from a point to the line, right? Okay, now here the question is find that coordinate that is closest to that line. Now we need to know a little bit from polynomial quadratic function to do this problem. Okay, but it has something to do with the vertex of the quadratic equation we have inside. It has something to do with that vertex. Okay, that's for number 7. I guess I don't want to go too far. Should I work on, yeah, should I work on this? I have only 15 minutes left, and this is the one I mark in purple is actually in your test too, right? So this number 7, maybe to be more precise, this number 7 here, 7b is the one from in your test 2. The one part A is actually doable in your test 1. It's doable at this point already. Okay, it's already doable in this at this point. How about this one? I do this word problem, so number 8 later. Let me focus on this number 9. Find the range of the function, and the hint is find the domain of the inverse. Find the domain of the inverse. Now remember, we did this though. I give you the sketch of the work, okay? But this get ready that this will be a question you see in your test 2 instead of test 1. The idea already enough from what we have right now. It is on the difficult side, okay? It is on the difficult side. So even though you can do this problem already at this point, but you may not have the maturity yet to do this problem. That's why I postponed asking this question until your test 2. After all, we focus more on functions in your test 2. Okay, but if you want to see the work right now, we can do that. Okay, the idea is this. Okay, to find the range of a function, you will solve for y. I mean, solve for x. You will solve for x, then read what y is okay. I believe I mentioned it somewhere here. Here. So you have a function, right? Okay, and the question is solve for x, right? For part B. And the purpose we solve for x such that on the other side only in terms of y. Okay, and then read which y is okay. Okay, that's the technique. That's the technique. Now the thing is, when you try that technique here, it will be quite complicated, but that's still the only way though. That's still the only way. That's still the only way. So let's solve for x first. I will solve for x. So y equals to x squared minus 3 over x minus 2. Multiplied by x minus 2 both sides. So xy minus 2y equals to x squared minus 3. Set one side equals to 0. Actually, I don't need to do this though. I don't need to do this. Anyway, this is y. You're right. I'm right. Okay, so I need to distribute my bad. And then I set one side equals to 0. Oh, what is the reason you set one side equals to 0, Thomas? This is the thing. Remember that we try to solve for what? For x, but read this right now. This x is quadratic, right? It is a quadratic equation containing y's. That's the painful part. That's containing y's. Let's rewrite it first. So we have x squared. That's the term with x squared minus yx. That's the term with x plus 2y minus 3, that's the constant term in when we see that. If we see if we see x as our variable, then 2y minus 3 is on the constant part. Okay, therefore, x12 is equals to, maybe we write this down first. What's your a? What's the a? What's the b? What's the c? The a is 1. The b is negative y. The c is 2y minus 3. See, the idea is simple, but it takes some maturity in doing precalculus level of problem in test 1 to be able to see this. Okay, but this is actually a quadratic equation if you use x as our variable. Now, so x12 will be negative b plus minus square root of b squared minus 4ac over 2a. In other words, let me continue here. Now, x12 is equals to y plus minus square root of y squared minus 8y plus 12 all over 2. Remember we say that we solve for x and then we read what kind of y will be okay, right? Okay, from there then we read what's the y so that this x becomes a real number. But x will be a real number when the guy here is non-negative. So I solve for x and then I try to read what y is okay. But when I look at this, oh, y will be okay if that expression is non-negative. Okay, so the domain, the range of that function is when the y satisfy this inequality. How to solve quadratic inequality now. Step 1, critical numbers. Long time no see. Factor whenever possible. Otherwise, then we use other method. So we get y equals to 6, y equals to 2. Next, we do sine graph. Y equals to 2, give me 0. Y equals to 6, give me 0. And when x equals to 0, this is when x equals to 0. Okay, when you plug in, I'm sorry, y equals to 0, actually not x. When I plug in y equals to 0, this will be positive 12. Right? That will be positive 12. So it's positive. And those critical numbers, 2 and 6, are critical numbers with multiplicity of 1. Odd multiplicity, so when I jump across the critical number, I change the sign. Then we are ready to answer the question. So the domain is, the range is the part that you have positive. It will be negative infinity up to 2 union 6 to infinity. Okay. Okay, but again, this is supposed to be the material you see in your test 2. It's doable already right now, but you will feel this to be quite heavy because your maturity level for your precalculus in your test 1 is not well developed yet. Okay, but by the time you get to your test 2, which is week 9, right, around 6 weeks from now, hopefully you already have enough maturity such that this question becomes something natural to happen at the back of your mind. Okay, I will stop here. See you on Monday, but of course tomorrow I will run lesson number 6 for my Tuesday Thursday class. Okay, so watch that lesson 6 from announcement 4, and during the weekend watch the recording from tomorrow's question and answer for their discussion. And hopefully then on Monday we come back, we can do a lot more problems from these 4 sets of questions. Okay, see you then on Monday.
Thank you.
You're very welcome.